Okay, this is Module 5, Lesson 7, and this is one of my favorite lessons. So we're going to find distance on the coordinate plane. Now, you see they have line segments up here, and they want us to give the points, the distance, and proof. You can't see the proof, but you will. So at the bottom, it wants us to determine the length of the line segments by determining the distance between the two endpoints, okay? So I'm going to actually go down here, and it's kind of hard to see, but I'm going to put points on my graph. So I make sure that I know, because they're kind of hard to see. So that's F, G, A, E, and then I'm going to do it over here with B. B is here, C, D. So I have my points on the coordinate plane. What I'm also going to do is, this is my 0, so I'm also going to label this. This is 1, 2, I'm going to label every other. So 1, this is 0 obviously, 2, 3, 4, 5, and so on and so forth. So I'm going to label each one 6, 7, 8, 9, and that's all I really need. And then these ones back here are negative, -1. So this is -2, -3. And I don't need to go any further because I don't have anything past there. These ones up here are positive. 2, oops, sorry, this is 3. 1, 2, 3, 4, 5, 6, 7, 8, and this is 9. So I have to be, I'm doing this so I can just find these right away. 2, 3, 4, 5, 6, 7, 8, 9. Okay? And then the other ones down here are negative. -1. That's 2. I won't write it because it'll be too smushed. -3, -5, -7. Okay. So I have that labeled. So the first end point is they want us to find line segment AB. So I'm going to say, okay, point A, I'm going to have my ordered pairs. So A is at, I'm going to go X first, remember, X, Y. If you need to, put it up here, X, Y, as a little reminder. These are your notes. So A is at -2, 8. -2, 8. Point B. Point B is at, oh, B is way over. B isn't down. B is at 9, 8. So B is 9, 8. So it wants to find the distance. I can go through and I can count every single tick mark, but there is a mathematical way with absolute value to find the distance. So I'm going to show you how. I'm going to do it once on here, and then I'm going to do it on a separate sheet of paper just so it's easier to see. So the proof is, if I line these up like this, and I cross out the ones that they're the same, and I say, and maybe you should write this on the top of your paper, same sign, subtract, different, add. So these have different signs, so I'm going to add them. So the proof is going to be the absolute value of -2, which is +2, different add, plus the absolute value of 9. 9 plus 2, there's my proof with absolute value, and the distance is 11 units. Now BC, well, I already have BC. B is 9, 8, and C is over here. C is at, I'm starting at 0, 9, 2. Now the units. You could do it like this. You can also just cross, I wouldn't cross them out and make it sloppy, but 9, 9, 8, that's B, and C is 9, 2, canceling them out. Same sign, they have this, these numbers have the same sign, so I'm going to subtract, so it should be 6. Because 8 minus 2 is 6, so absolute value of 8, the bigger number goes first when you're subtracting, otherwise it's a negative number. Whoops, minus the absolute value of 2, sorry. And that should be 6 units. Okay, the next one, C. C is at 9, 2, I have that already. D, point D, so I'm going back on my graph. D is at, start at my 0, D is at 9, negative 5. 9, negative 5. Going to do it on my scrap piece of paper. 9, 2, 9, negative 5. Cross out the ones that are the same. Same sign, subtract, different, add. So this is different signs. I have a negative and a positive. I'm going to add. So it should be 7. Absolute value of negative 5 plus the absolute value of 2. I can't see that. Remember, absolute value signs are those long bars. They look a little longer than a number 1. Is 7 units. Okay, B, D. Well, I already have B. B is at 9, 8, and D is at 9, negative 5. So, here's my scrap paper. 9, 8, 9, negative 5. Cross out the ones that are the same. Look at these. Say same sign, subtract, different, add. They're different. I have a negative and a positive. So different, add. So that's going to be my proof. The absolute value of 8 plus the absolute value of negative 5. 8 plus 5 is 13 units. Okay, and we're going to go, I'll do one more because you can fill this in on your own. So D, I have D, DE, D is at 9, negative 5. And E, if I go to my chart, here's 0. So this is negative 2, negative 5. So here's my scrap paper. 9, negative 5, and negative 2, negative 5. Cross out the ones that are the same, and I say same sign, subtract, different, different. I have a negative and a positive. Different signs, add. So 9 plus 2 is 11, but I need to proof it with an absolute value statement. So absolute value of 9 plus the absolute value of negative 2, sorry. So absolute value of all of these are positive because absolute value, remember, is always positive. So 9 plus 2 is 11 units.